Welcome to Microlecture 11 on pKa values. So what is a pKa value? A pKa tells you how strong an acid is. So the lower the value, the stronger the acid. pKa's of very strong acids that completely dissociate in water, like HCl, are negative. And just to get an idea here of the range of pKa values, we know that water and alcohols with OH groups are species that can pick up a proton or give a proton away. So they can act as acids or bases. Species like that are going to have pKa values around 10 to 16. So an acidic pKa would be something below that. Here we see acetic acid has a pKa of 4.76. On to the other side, something like a hydrocarbon is highly unlikely to give up a proton, and so its pKa value is huge at about 40. We often use pKa values to distinguish between molecules in terms of which one will be more likely to give up a proton. Here, which one would be more likely, A or B? And so with a pKa of 7.15, B is more likely to give up a proton. And you can see in the resulting conjugate base that there's some resonance involved in the formation of this conjugate base. So we'll get back to that later. For now, just make a mental note that there are very good reasons that we can explain for why some compounds are more likely to give up a proton than others. So what is a pKa in a mathematical sense? Well, recall Ka. That was our equilibrium constant for acids. Remember, it's the concentration of products over concentration of reactants. So in an acid-base reaction, that would be the concentration of the conjugate acid times the concentration of the conjugate base divided by the concentration of the acid times the concentration of the base. Well, the pKa is just the negative log of that value. So pKa equals negative log of Ka. Now, if you take the negative log of a large number, you're going to get a small number. So if the pKa is small, that means that the compound is acidic. That will correlate with a very large Ka. So a very large Ka usually means that this is a species that dissociates readily. Here's your example problem. You have choices A, B, C, D, and E, and you want to choose which is the strongest acid. So you have a table of pKa values on the right-hand side. Pause the video and see if you can find the strongest acid. If you guessed E, you were correct. Acetic acid has a pKa of 4.75. D is shown just below that. So we can see that it has a pKa of about 9. Ammonia, we know, is a base. So we have to use a little bit of chemical intuition there. It's not on this table. Neither is B, but we're abstracting from a hydrocarbon, and if you recall, that's not very likely. It turns out this is the most acidic type of hydrocarbon. It would have a pKa of about 25. Trying to take a proton off of a hydrocarbon is not easy, unless there's some driving force, and that's the case with the proton that we grab off of the compound D. So we will talk about situations like that and what makes that compound more acidic. And lastly, the CH3CH2OH, or ethanol, compound A, is the second to last one with a pKa of 16.